Hey guys, it's Sonali. Welcome to another session of Full STEM Ahead. In today's video, we're going to be talking about a fascinating puzzle called the Fibonacci sequence. What is the Fibonacci sequence? The Fibonacci sequence is a series of numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. The next number is found by adding up the two numbers before it. The 2 is found by adding the two numbers before it, 1 and 1. Similarly, the 3 is found by adding 1 and 2. And the 5 is 2 and 3. This pattern continues as you can see in the diagram. The rule. The Fibonacci sequence can be written as a rule. The nth term equals the nth term minus 1 plus the nth term minus 2. In other words, let's use an example. The 8th term equals the 7th term plus the 6th term. As you can see, 21 equals 8 plus 13. A pattern. Looking at the chart, there's an interesting pattern. Look at the third term. The third term equals 2. Every third number is a multiple of 2, if you can see. The third term equals 2. The sixth term equals 8. The ninth term equals 34. The 12th term equals 144, and so on. Look at the fourth term now. The fourth term equals 3. Every fourth number is a multiple of 3. As you can see, the fourth term equals 3, the 8th term equals 21, and the 12th term equals 144. Look at the fifth term now. Every fifth number is a multiple of 5. The fifth term is 5. The 10th term is 55, and the 15th term is 610. This goes on forever, basically. Every nth number is a multiple of the term n. Past and present. Fibonacci's real name was Leonardo Pisano Bugallo, and he lived between 1170 and 1250 in Italy. Fibonacci was not the first one to know about the sequence. It was known in India 100 years before. Fibonacci was his nickname, which roughly means son of Benaki. As well as being famous for the Fibonacci sequence, he helped spread Hindu-Arabic numerals like our present numbers 0, 1, 2, 3, 4, 5, 6, 7, and 8 through Europe in place of Roman numerals. That saved us a lot of troubles. So, let's thank Leonardo. Spiral and squares. Look at the spiral these numbers make. Kind of looks like a snail shell, don't you think? When we make squares with those widths, we get a nice spiral. Do you see how the squares fit so neatly together? For example, 5 and 8 make 13. Squares 8 and 13 make 21. And so on. Fun facts. Did you know if you divide a Fibonacci number by the number before it, as n approaches infinity, the ratios produced settle into what's known as the golden ratio, or the golden number, approximately 1.618034. Fibonacci numbers are illustrated to be an approximation of rabbit growth population. Isn't that cool? It has also been applied to cow population and honeybee population. Neighboring Fibonacci numbers have no common factors. See for yourself. Most flowers have petals that are Fibonacci numbers. Famous examples include the lily, which has 3 petals, buttercups, which have 5, chicories, 21, and the daisies, 34, and so on. The Fibonacci sequence has been used in the visual arts because it's believed to produce aesthetically appealing images. Even Leonardo da Vinci used it. It has also been used in music, most notably by Mozart. Every 23rd of November, 2311, is celebrated as Fibonacci Day because the date and the month combined in reverse gives gives digits of the Fibonacci series sequence 1123. That's really cool. Maybe we should all celebrate Fibonacci Day. So guys, I hope you found this video fascinating. I think I learned a lot from the Fibonacci sequence. I hope to see you next week on Full STEM Ahead. Bye! Thanks guys!